So, lots of vocabulary, but I'm not just going to kill us with vocabulary here to begin with. We're going to define a vocabulary term and then use it when it's applicable, and then we'll come back to it when we need later on throughout the problem. So, I actually want to begin with this. Okay, before we start any vocab, as I was writing them down today, I'm like, you know what? I want students to start to understand what things represent and not just make this like a fancy vocabulary term and I don't know what I'm doing or why I'm saying it or whatever. So if I were to ask you to graph this inequality right here. Okay, this is something we just got done doing. We graphed linear inequalities. It was one of our 4 standards on our most recent assessment. Okay? You would take a number line, and we would have 0 here. We'd go 1, 2, 3, 4, and 5 here. And the first thing we'd have to determine is what? What type of dot we need. And what type of dot would we need in a problem like this? Why open? Because there's no equal sign, so what's the open dot represent? That it's not a solution to it. Okay? So we'd put an open dot above 5 because it shows that it's not a solution to that problem. And then we'd have to go and say, well, I need to shade one way or the other. Okay? So remember, if I plug 0 into this, is 0 greater than 5? No. So what would that tell me to shade? Tell me to shade to the right. Okay? So somebody tell me this. What does this graph show? I mean, we know how to graph it, but that's great. But I'm asking you, what does it show? Carla. Okay, so that tells us why we have to shade to the right, but here's my question. What does the graph represent? What is this telling somebody? What's the shaded part to this? Carla? These are all the numbers that are bigger than 5. And you might say, well, duh, that's why we shaded that way. Yes, but here's what the thing is. This shows all the numbers that make this inequality true, doesn't it? Okay? That's what a graph of a number line shows. It shows all the solutions. Because how many solutions are there to this inequality? There's an infinite number, right? But this graph shows all of them on the same graph. Okay? Now, when I say there's an infinite number of solutions to this inequality, does that mean that you can pick anything you want? No. You have to pick a number that is what? Greater than 5. But every number that is shown on this graph, which is shown because it's shaded, represents a solution to this inequality. Okay? And I think for one variable, and tying this in with something we've already done, I'm hoping that makes sense. I don't just want you to know how to graph. You need to know what a graph is showing. Okay? It's showing all of the solutions of this inequality. Why am I bringing this up? Because today we're going to talk about solutions of 2 variables as opposed to 1. So how do we show that? Well, instead of graphing it on a number line, we graph it on 2 number lines. And guess what we call something that's got 2 number lines? The coordinate plane. That's all you're doing is you're graphing on an x-axis and a y-axis. And a number line for the x's and a number line for the y's. And you're going to show solutions with that. So the same thing that this is representing in 1 variable, we're now going to transfer over to 2 variables. Okay? That's what I want you to keep in mind. So if you're still if you're puzzled, well, what is this showing in this? I want you to ask, because these are like the big ideas. When we get the big ideas, all of the small ideas that we're really trying to focus on, they kind of take care of themselves. Okay? All right, so let's start with our 1 definition. A solution of an equation in 2 variables is an ordered pair that produces a true statement when the coordinates are substituted I'm going to have to go to line 3 here, for the variables in the equation. Sorry, variables in the equation. Again, I'm going to try and draw parallels back and forth to these as we go. Okay, so I'm going to jump from one variable to two variable because we're hopefully pretty comfortable with one variable equations and graphing and everything else. We've got to see how this is transferring over to two variables. Okay, so if I were to ask you this question, is 4 a solution of 3x minus 10 equals 2? This is a question that you've been asked already this year, correct? And what I told you was I don't want you to solve this equation. Okay? What did you do to determine if 4 was a solution? You what? You plug in that number for the variable. So, we would plug 4 in for x, and we would simply simplify each side of this equation, right? So we'd get 4 times 3, which is 12. Okay, 12 minus 10, which is 2, and we'd get 2 is equal to 2. So what would we answer to this question? Yes, 4 is a solution. Okay? So we did it with one variable. We did this a long time ago. We're in Unit 4. We did this at the very beginning of Unit 2A. It's been a long time. But in order to determine if a number was a solution, it meant that you replaced the variable with that number and then determine whether or not it made the equation true. Okay? So, think about this. This is all this is telling us here. Except now this equation is going to have two variables. And what do we plug in for those two variables? We plug in an ordered pair. So in order to be a solution of an equation in two variables, you must have an x and a y value that you are going to plug in, and you're going to see if it makes the statement true. So, let's slide right down to example number 1. Okay? So in example number 1, it asks, tell whether the ordered pair is a solution of the equation. Okay, so here's what's different than the previous problem. In the previous problem, they asked if a number was a solution. Now we're asking you, is an ordered pair a solution? And also, here's what's different from what we've done so far. Your equations previously had one variable. Now your equation has two variables. Okay? Well, what you do really doesn't change. You've got to substitute the values in for the variables. Now, our variables that we're going to use all the time are x and y because those correspond to ordered pairs. So, when I go to do my substitution, what am I plugging in for x in this problem? 2. What am I plugging in for y?